It is asking that question number 1, draw the systematic diagrams of the circuit, the battery having 3 resistors. We need to make it systematic diagrams in which 5 ohm resistor, 8 ohm resistors, and 12 ohm resistors are connected in series. Okay. So what is this asking that what is the redraw the circuit diagrams in question number 1, and let's have this question. Okay. So if we have this question and we need to solve this question, then how can we solve this one? So let's. So we need to draw the systematic diagrams containing a battery of, means here it is 2-volt battery each, and this is 2-volt battery, means there are 3 2 volts battery each. Total voltage will be, okay, then positive terminal, then negative terminal, and then positive and negatives are connected, then negative. Okay, so this is one battery, this is second battery, okay, and then positive, and then negative terminal will be like this. Okay, this is the third battery, third cell. Okay, so these are two voltage, so total voltage will be 6 volt. This is positive and negative. Okay, you need to keep in mind that there should not be two positive terminals, means two big lines should not be here. It should be smaller. One should be greater here, positive, and another should be smaller here, like this way. Okay, and it is being asked that 5 ohm and 8 ohms and 12 ohm resistors are connected in series. So it is 5 ohm, then 12 ohm, and then 8 ohm. 3 of them are connected here, and so we can make this systematic diagram here. Okay, and we can plug in one key, 1 ampere meter, I feel like this. So we can plug it one key here, like this. Key can be placed anywhere. It is not necessary that you need to place. Okay, and you can place 1 ampere meter here. Okay, or you can place ampere meter here, or you can place anywhere, because ampere meter is always connected in series. Okay, so it is being asked in the question number 1, putting the ampere meter to measure the current through the resistors and voltmeter to measure the current across the 12 ohm. So this is 5 ohm, this is 8 ohm, and we are just because voltmeter is always connected in parallel. Okay, so we connect it like this way. Okay, this is the voltmeter, and it is being said in question number 2, the second part of this one, the redraw this one. Okay, and voltmeter is measured, means here 12 ohm resistor ke across 12 voltmeter has been placed. Okay, voltmeter to measure the potential difference of across the 12 ohm resistors. So we have placed voltmeter like this across the 12 ohm resistors. What would the reading of ampere meter and voltmeter? So you need to calculate the voltage and I. So please calculate it. Calculate it fast. Are you calculating? First of all, calculate the equivalent current, equivalent resistance in series, and then by getting the formula, you will have R equivalent is equals to V equivalent upon I equivalent.
So can you repeat again? I couldn't hear you.
Yeah. I'm saying that calculate the equivalent resistance here.
Oh, okay.
Equivalent resistance. So what is equivalent resistance? In series it would be, tell me Abir.
It will be R1 plus R2
plus R3. Okay, so that will be R
plus
equivalent will
R3.
be 5 plus 8 plus 12. So it will be 5 to 17, 17 at 25 ohm. Okay, so it is 25 ohm, and what is being asked here? Value of I. So I will be V by R. So V is 6 and R is 25. Okay, got it? Because we have 2 volt each cells. Okay, battery consisting 3 cells each of 2 volts. So it will be 6 volt total. Okay, so you need to keep in mind, don't think that the voltage is to read the statement properly. Okay, so I is equals to Okay, V by R. So
Yes, sir.
V is actually 6, and this, so this is I. This is the ampere meter reading. Okay, and the same ampere meter reading means same current, because in series current remains same. The same current will pass through this one, same current will pass through this one, same current will pass through this one. Okay, got it? Got it? And
Yes,
if
sir.
this, if the same current is passing, and if I ask you to calculate the value of V across it, so V is equals to V across 12 ohm. V across 12 ohm resistor equals to V is equals to I into R. Okay, so I across 12 ohm, okay, into R, that is 12. Okay, so I is actually, V is actually, sorry, I is actually 6 by 12 across, because V is, I will remain constant in this one, in this one, and this one. The same, into R is actually 12. So you got it. So now it is 25. It is 6 by 25 into 12. Okay, got it. So this will be the value of whatever you get. This will be the value of 680.25 volt. Got it. This will be the voltage reading across 12 ohm resistor. Done.
Noted, sir.
Okay.
One
Next
second, sir.
question.
That's
Okay. Next. Next is okay. You have question number 1. Read the question number 1 and answer the question. Just the equivalent resistance in each of the following case if they are connected in parallel. Okay. So if we have 1 ohm and 10 lakh ohm resistance connected together, then what will be the equivalent resistance in parallel? It will be less than 1 ohm. Okay, because it is being asked. So you need to, I have also discussed this one in the previous class, that if there is n number of resistors are connected in parallel, so the answer will be less than the value of least resistance. So here it is 10 lakh ohm and this is only 1 ohm. So the answer will be less than 1 ohm. Okay, got it?
Yes, sir.
And here, if we have 3 resistors connected in parallel, the answer will be still less than 1. Okay, because the 1 ohm is the least resistor. Okay, got it? Got it?
Yes, sir.
Okay, do question number 2. Do question number 2. Are you solving? Electric lamp of 100 ohm and a toaster of 50 ohm and a water resistors of 500 ohms are connected in parallel with 220 volts. What is the resistance of the electric currents when what is the resistance of the electric current connected to the same source and take as much as current as C is taking? Okay, and what is the current flowing through it? So you need to simply find out the equivalent current. Okay, means they are connected in parallel. So first calculate the equivalent resistance of these three and then you will get the equivalent resistance, and then you have voltage. In voltage is going to be same in all cases. Okay, are you getting my point, what I'm saying? Are you getting? Abir, are you there?
Yes, sir.
So if we have this one, let's suppose if we have 100 ohm, so R equivalent will be 1 upon 100 plus 1 upon 50. In parallel, we do like this. Okay, and then 1 upon 500. Take the LCM, 500. Then this will be 5 plus 10 plus 1. You will get 16 by 500. Okay, 1 upon R equivalent. So R equivalent will be equals to 500 by 16. Get it? And then you have get this one. Then find out the value of I. Done? So if it is asking an electric lamps and a heater, they are connected in parallels, and what is the resistance of the electric iron connected to the same source takes as much as current as the three appliances are taking. So current, if they are taking same, so their equivalent resistance will be same. Okay, got it? Are you getting my point?
Yes, sir.
So here, if we have R is equals to R equivalent is this one, then what's the value of? We need to calculate the value of I. So I is equals to V by R, or you can write V into 1 by R. So what is V? V is 220. And what is 1 by R? 1 by R is 16 upon 500. 2020 will get cancelled out. Okay, and this 5 and 16 will be 32 by 5. Multiplied by 2, it multiplied by 2, you will get 10 upon 64, you will get 6.4 ampere.
Sir, the volt is 220, right?
Oh, voltage is 220, we test it with 200. Okay. Okay. So voltage is 220. So do it with 220. Let it be 220. Okay, this is 500. Cancel 10 with 10. Okay, and whatever the answer comes, 2 into 16 by 50. Okay, just multiply. You can write it 22 into 16 by 50. So multiply this by 2. Multiply this also by 2. Okay, so what you will get here? 44. 44. And this is 100. 44 into 16. 44 into 16 can also be written as 11 into 16 for the 64. Okay, I multiply 4 with this one and I just separate it. So now is multiplication with 11 is very easy. You will get 64 and then 64, you will get 407, 704. And then you have to place the decimal 7.04 ampere. You do the calculation. This is my way of calculation. You can do it by your own. The answer will be simple. Okay. Got it? Copy this one. Done?
Done, sir.
So here you can do in a very simple manner. That is here you will have the current as 7.4 ampere. Okay, and the equivalent resistance of the iron which is drawing the same current. So it is asking what is the resistance of an electric iron if it is drawing the same current. So our resistance will also be the same because the voltage is same. Okay, so the resistance of that one will be the equivalent of all these three. Okay, got it? So next question. Question number 4. Do question number 4. How the three resistors can be connected? so that the total resistance will be one time you get when you connect all these three. Connect all these three such that you will get equivalent resistance as 4 and connect all these three such that you will get equivalent resistance as 1.
Sir, for one, we should do it in parallel series.
Yeah. Actually, here in case, if you are going to get, if you have connected all these three in parallel, then you will get the answer less than 1 because the least resistance is 2. So less than 2 will be the answer. Okay. It can be 1 or less than 1. Okay. If you are connecting all these three in parallel, then the answer should be less than 2 because, but here we need 4. And if you are connecting all of them in series, then the answer should be more than 6 because if you are
Yes,
adding,
sir.
okay, but in we are having 4, which is neither less than 2 nor it is greater than 6. So there must be 2 resistors in series and 1 in parallel, or it can be 2 resistors in parallel, 1 in series. Okay, check
Yes,
it,
sir.
check it which in which and how will you connect these two. Check it.
Sir, we can connect 3 and 6 in parallel and two in series with 3 and 6.
Yeah. We can do this way. That if we connect 2 in series and this 3 ohm and 6 resistance in parallel. Okay. So this is 3 ohm, this is 6 ohm, and this is 2 ohm. Okay. So we will have two, we will later do it later. Okay. So now calculate the equivalent resistance of these two because these two are connected in parallel. So we can have 1 by 3 plus 1 by 6. Okay. Then take the LCM. R equivalent here. Where will be equals to what? Tell me. Of these two resistors will be, you need to make the LCM 6. So 6. So here for making
2
6, you need
plus
to
1 by 6.
2 plus 1, you will get 3 by 6, you will get 1 by 2. Okay. So R equivalent will be reciprocal of these two, that is 2 ohm. So instead of these two, we can write 2 ohm resistors. Okay. This 2 ohm is already here and the equivalent of these two is 2 ohm. So the equivalent of overall of this two will be 2 plus 2 will be 4 ohm. Okay. Because now they are connected in series. Understood? Are you getting my point?
Yes,
Everybody in the
sir.
class? Ammar, Saima, are you getting?
Yes, sir.
Ammar, are you there?
Yes, sir.
Okay, now you see here, you check here that the equivalent resistance we need to calculate is 1 and 1 is less than the all the three resistors. So it is must that all the them three must be connected in parallel. Okay, got it? So if we have 2 ohm resistor, then 3 ohm resistors, okay, and then 6 ohm resistors. Okay, and if we need the equivalent resistance of these three as 1, which is the 1 is less than the least resistors, the value of least resistor. So this is only possible if we connect them all in parallel. Okay, like if we all connect them all in parallel, this is 6 ohm, 3 ohm, and 2 ohm. So you will get 1 by 6 plus 1 by 2 plus 1 by 3. Okay, so you multiply this by 2, this by 3, so this by also the 3, this by 1, so this by also 1, so you will get 1 plus 3 plus 2 on 6, you will get 6 by 6. So 1 upon R equivalent. So R equivalent is also equals to 1 ohm. Got it? Got it?
Yes, sir.
Yes, sir.
Okay. Question number 5. Question number 5. What is the highest and the lowest possible resistance?
So lowest should be less than 4, right?
Yes, but we need to calculate the exact value. Connect them all in parallel and then get the value. This will be the lowest, and connect all, add all these, and they are connected in series. You add all these, this will be the highest possible. Okay.
Sir, the highest is 48 and the lowest
Lowest
is
is 1 by 2.
it's 2.
1 by 2 or 2?
2.
Yes, Abir, lowest will be?
Sir, I got 1 by 2,
You
lowest.
got. Okay, let me check. It is 2 or 1 by 2. So if we have lowest is 1 by 4 plus 1 by 8 plus 1 by 12 plus 1 by 24. Okay. 1 upon R equivalent. We need to add all these. So we'll take the LCM as 24. So what by what number should 4 be multiplied to get 24? 6.
6.
By what number should this be multiplied to get 24?
3.
3. By what number should this 2? This one.
2.
We will get 24 and this we will get 6 and 9, 9 and 3, 12. 12 is 1 by 2 is 1 upon R equivalent. So R equivalent will be 2. You did mistake here, Abir. This
Yes,
is
sir, I
actually
didn't take reciprocal.
yes, you didn't take this reciprocal. And the highest will be 4 plus 8, 12. And 12, 12, 24, 24 and 36. So 36 ohms, sorry, 12, 48 ohms will be the highest one. Okay. Got it?
Yes, sir.
So I answer for this.
You didn't understood? Yes, Amar?
No, so I also got the same. No, so I also got the same thing.
You got the same thing. Okay. But you understood my questions?
Yeah.
Yeah. Okay, thanks. Okay. Do question number 12. When 12 volt battery is connected, sorry, question number 8. Question number 8. Do question number 8. Okay. This one. So when a 12 volt battery is connected across an unknown resistors, there is the current in the circuit is 12.5 milliampere. What's the value of resistance? Calculate it.
Sir,
Yes. Yes.
sir, how many milliampere is 1 ampere?
10 raised to the power minus 3. 10 raised to the power minus 3 milliampere is equals to 1 ampere. Done. This is very simple. Abir, done. Done? This is very simple. How much potential difference is given to you? V is given 12. R is given.
Sir,
I need to
resistance
find
is 0.4 into 10 raised to 3, 10 raised to 4.
0.3
0.4 into 10 raised to 4.
10 to the power 4. Let me check. So, we need to calculate R is equals to V by I. So V is 12. I is 2.4 into 10 raised to the power minus 3. Remove one decimals, you get 10 here. Okay, you will get 120 divided by 24 into 10 to the power 3. You cut it, you will get 5 times. 25 5 the 24 5 the 120. Okay. Then it will be, this will goes to upside, this will be 5 into 10 to the power 3.
Sir, can you show the question again?
Let me check. 12-volt battery. Here, this one, 2.5 milliampere. So what I take? Do I take 2.5? Oh, I take. I'm just taking the values according to me. It is 2.5 milliampere. Your answer is correct. The answer is correct. It's 2.5 milliampere. It is 2.4. I just took 2.4. I don't know from where it does comes to my mind. It is 2.5. Okay. Now, when you get the value, you have to divide. Now this has been removed. A 25 need to be divided by. So you will need to calculate the value up to 2 decimal place. Okay. So this will goes up. You will get going to have 10 to the power minus 3. But here you will have 25. Okay, 25 need to be divided by 1. So you will get 4 the 100. Then you will get 20. And decimal is already there. Okay, put the decimal and then 8. 4.8. This will be 4.8 into 10 to the power 3. Okay. Got it? Got it, Abir? Amar? Saima?
Yes, sir.
Okay. Next question. Do question number 9. Question number 9.
Sir, I is 0.75.
I is 0.75. Let me check. A battery of 9 volt is connected to a series of 0.2, 0.3, 0.4, 0.12 and so on. How much current flows through 12 ohm resistors? So actually in series, we need to calculate it. It is indirectly asking the current. Okay. Okay. Let you check here. Okay. For example, if we are having this question. Okay. A battery of 9 volt connected in series to a resistors of 0. This and this. So first you need to calculate the equivalent resistance. What would be the R equivalent? 0.2 plus 0.3 because we are connected in series. Okay. So 0.4 plus 0.5 plus 12 ohm. So this is 5 and 5. You will get 1 and 1.4. They will get 13.4 as a total. Oh, so this is R equivalent. Got it? Understood?
Yes, sir.
Yes, sir.
Now,
Sir, but since current will be equal in all the resistors, we can just directly calculate by I is equal to V by R.
yeah. You have to calculate. Actually, he's just means this that we need to calculate. We need to the whole current, the same current will be there. 0.2, okay, then 0.3, then 0.4, then 0.5, and then we'll have 12 ohm. The same current will be there because the current in the circuit is same and current in series remains same. So whatever the current in this one, it will be also same in this one. Okay, the whole current is, so we can calculate the current. So we have I is equals to V by R. V is actually 9 volt here. And R is 13.4. Get 10. So whatever the current comes, okay, then let's say 3 plus 5, 5 plus 3, 8, not divided by 9. Okay. So whatever the value comes here, this is 90 by 134. Okay. So that value will be equal, the current will be here, okay? The same current will be here, okay? Got it? Understood?
Yes, sir.
Yes, sir.
So you can write 9 by 3.4 or you can do this 112 decimal place, okay? That will be same. Now if I ask you that what is the potential difference across 12 ohm resistor? What is the potential difference across 2 ohm resistor? 12 ohm
9.
resistor.
9.
No, not 9. In parallel, the potential difference remains same, but here is the in series potential difference divides.
9 by 5.
Abir, you tell me on a mark.
So it should be current into resistance.
Yes, because we
So
have formula.
108.
Not 100. It cannot be greater than 9. So what is the value of I? I
Sir,
is
is
this
it
one.
1.8?
9 by 134 into R is 12. Okay.
Yes, sir.
The current in this resistor is the same, that is 90 by 134. And what is the resistance of this one? Is 12. So 12. Okay. So V is equals to I into R. So I across this resistance into R, 12 ohm. So that would be the value of V. Okay. Got it?
Yes, sir.
Yes, sir.
Okay. Okay. Next question. Do question number 11. Now question number 10. First question number 10.
Sir, is it 44?
Question number 10, 44. No, not 44. How many resistors of 176 ohm in parallel will required to get a current of 5 ampere on a 20 volt line?
Sir, sorry, it's the 4.
Yes, it is 4. You did, Kabir and Amar?
No, sir. Can you explain this question?
Yes. How many? So what is, I have told you that if you have R resistors, or we have n number of resistors and they are connected in parallel, okay? That you have 5 ohm resistors and they are 100 resistors. 100 5 ohm resistors are connected in parallel. So if you need to calculate the resistance, and what should be? It is simple that R equivalent in parallel will be equals to n R each divided by n. R each divided by n means 5 divided by n is 100. Okay. So you will get 0. Whatever the answer comes. Okay. 5 by 100. Okay. So if same resistors are connected in parallel, then their equivalent resistance is R each divided by n. Okay. So R equivalent in parallel is equals to R each divided by n. Okay. Understood? And if we have the whole current, and R is also equals to, R equivalent is also equals to V by R. So V by I. Okay. V equivalent upon I equivalent. Okay. Understood? Or we can say R is equals to V by I. Don't write equivalent each time. Okay. So where V is the voltage across the circuit and I is the total current in the circuit. Okay. So you can write the formula here that R equivalent will be equals to V by I, and that R equivalent value will be equal to R each divided by N. So what is the value of R each? There are 176 ohm resistors and N is here. We need to calculate the value of N, that how many resistors are there, and V is 220 and I is 5 ampere. Okay. So divided by 5, you will get 44. And when you divide by 44, okay, now this is a reciprocal this and reciprocal this, or you can have n is n, take the n here and bring this 44 to downside. Okay, so it's your choice. It is just simple calculation. So bring the n to this side. This is 176. This n goes to upside to there, and this 44 comes down. Okay, you cut it, you will get 4. So n is equals to 4 resistors. So 4 such resistors will be required. Okay, got it? Got it?
Yes, sir.
Okay. Next, have you noted this question? Note this question first.
Noted, sir.
Done, everyone? Okay. Next, moving to the next part here. Hmm. Do question number 11. Do question number 11. Are you solving?
Yes, sir.
Okay.
So to get 9 ohm, we connect two in parallel, then that one with one in series. And to get 4 ohm, we connect two in series with one parallel.
2 in series with 1 parallel. Yes. So if we have we have 6 ohm resistors, 6 ohm resistors. Okay. And if we need to connect them and we need to obtain 6 ohm or 9 ohm, sorry, 9 ohm. So 9 can comes when we are going to have 1 in series, because if we have 6, okay, so 6 is fixed. If we are connecting 6 ohm in series, then the answer should be greater than 6, because whatever you are getting in other two by adding in parallel, okay, you will add these two with this one, okay, whatever the resultant of the other parallel, okay, you are going to add. So if the answer is 9, so 1 at least you need to connect in series. Why? Because you are getting the answer more than 6, and if you are connecting one resistor in series, then you will get 6 plus something, and 6 plus something is greater than 6, that will give you 9. Okay, so this is only the combination when you are having 2 in series and 1 in sorry 2 in parallel and 1 in series. Okay, so you have 6 ohm and you have 6 ohm. The equivalent of these two will be 1 by 6 plus 1 by 6.
3.
You will get 6 by 2. You will get 3, 1 by 3. So you reciprocal this, you will get 3 ohm. So 3. Now you can make this one like 6 ohm, and the equivalent of these two is 3 ohm. So that will be equals to 9 ohm.
9
Okay.
ohm.
Understood? Ammar, understood? Abir, understood? Hama?
Yes, sir.
Okay. Now, if you are going to have 4 ohm as an equivalent resistance, second case is 4 ohm. Okay, 4 ohm. So you need the answer less than 6. Less than 6. And our all equivalent resistance are of 6 ohm each. Okay, we have 3 resistors which are 6 ohm each. Now, if you connect them all in parallel, you will get answer R each divided by N. That is 6 divided by 3, you will get 2 ohm. If all 6 resistors are connected like this, are all in parallel, you will get 2 ohm. But the answer is greater than 2. So how will you connect? So you are not going to connect any resistance in series, because if you connect anyone, if you connect 6, then you will get the 6 resistors, 6 ohm resistors in series. So you will get answer 6 plus something. So how you will connect to get 4? You have to connect these two in series and then a parallel along with these two. 6 ohm. So now this 6 and 6 will add up and it will gives you 12 ohm. And now this is in 6 ohm. Okay. So what's your answer? 1 by 12 plus 1 by 6. You need to calculate R equivalent. So now this is 2. This is also 2. You will get 12 by 1 plus 2. You will get 3 by 12. Cut it, you will get 1 by 4. So R equivalent is 1 by 4. So R each will be 4 ohm. You understood? Understood?
Yes, sir.
And okay,
Yes.
let's move further. Now these are all powers. Wait. Okay. Okay. Here we have question number 20. So here it is saying that two 2 ohm each resistors are connected in such a way, each is distributed energy and resistor maximum resistor. So this is a power. So let it be. Circuit of an electric circuit containing a cell, key, and ampere meter of resistors 2 ohm in series and combination. What will the potential difference across 2 ohm resistor will be same as the as that across the. Okay, do question number 22. Do question number 22. Fast. Done. Draw a circuit of an electric. Draw a circuit diagram of a circuit containing a cell, key, and ampere meter of resistance 2 ohm in series with a combination of two resistors in parallel and a volt meter across the parallel combination of this one. So let's draw this one. Okay, so let's have this question. Draw a circuit diagram of an electric circuit containing a cell, an ampere meter, and a resistors of 2 ohm in series with a combination of two 4 ohm resistors. So this is 2 ohm in series with a combination of two 4 ohm resistors. Okay, got it? Will the potential difference across 2 ohm resistors will be same as across the parallel combination of 4 ohm resistors? Means will the potential difference. So will the potential difference remain same? Tell me.
Yes.
No, how can it? It is when parallel. So it is in parallel, but here if the potential difference is being asked in this one and this one will be same, yes, because these two are in parallel. But actually this resistor and this resistors are in series with each other. Okay, these are not in parallel. Got it?
Yes, sir.
So what is being asked here? That let does this question. Let's calculate the potential difference across this 4 ohm resistors and this 4 ohm resistors. And with which would how many let's if it is no voltage is not given, so let understood that it is connected. Let for example, let I'm having it is connected with 12 volt battery. Okay, got it. Now the current across the circuit across this ohm, tell me current across this resistors. So first you need to calculate the equivalent resistance. So this is 4, this is 4. So 4 ohm resistors are connected. So equivalent resistance of this two will be R each divided by N,
Two.
and 4 divided by 2, you will get 2. Okay. R each, because both are equal. So 4 is 4 ohm are there. So write 4 and divided by 2, you will get 2 ohm. Okay. So this is also 2 ohm. Okay. 2 ohm. Now, if it is being asked that we need to calculate the current. So total current in the circuit will be total resistance. Equivalent resistance, tell me.
4 ohm.
That
2
will be
plus
4 ohm. Okay, the total current I is equals to V by R. Okay, so V is actually 12 and R is 4. Okay,
So 3.
so that 3 ampere. So 3 ampere current will pass through it through this one. Okay, 3 ampere. Okay, got it. 3 ampere current will pass through these two. Got it. Now up to here the 3 ampere will be here, but out of this 3 ampere, now at this point, since these two resistance are equal, so 1.5 ampere will pass through this one and 1.5 ampere will pass through this one. Okay, again then it will again combine here, and then again it will form 3 ampere. Okay, got it? You understood?
Yes, sir.
So this way you need to do this one, that suppose this is simply connected, this is in parallel, so this is in series, and this 4 ohm resistor and this 2 ohm resistors are in parallel, so they will not going to have the same current. Okay, because they are sorry, they are not going to have same potential difference. Okay, now let's it is asking that about the potential difference. Okay, let's check. So first it may have same potential difference. Okay, let's check. Okay, let's check. So what is being said here? So we need to calculate the potential difference. So potential difference is I into R. Okay, got it. So if I need to calculate, okay, if I need to calculate, last question of this one, if I need to calculate the voltage across these, if I need to calculate the voltage across these, then what will be the, tell me. If I need to calculate the voltage across these, then we can calculate the voltage. We have calculated the current here, 3 ampere, here 1.45 ampere, here 1.5 ampere. So actually V here will be I into R. So I here is 3, so right here 3, and R is 2. So this is
2.
6 volt.
6
6
volt.
volt. Okay. And here 1.5 into 4, you will get 6, and 1.4 into 4, you will get 6. So both of them are going to have the same potential difference. Okay. Got it? But different current will be there. Got it? So if they are asking that will the potential difference will be same? Yes. Why? Because here this resistance is going to have 1.5 ampere current, and the resistance is 4 ohm. So you will get 6 ohm. Okay. And here also 6 ohm. Sorry, 6 volt. So both of them are going to have 6 volt. Got it? Understood?
Yes, sir.
Yes, sir.
So let's start studying the chemistry. Okay. So we continue on the next hour. Okay. So in the previous class, what we are studying in the chemistry? Tell me what we were studying in the chemistry.
Carbon and compounds.
Yes, carbon is compound we are studying. So wait a minute. Dear students, because Hamid sir is not available, he is suffering from dengue. Okay, so it's my request that today I need to take your class. Okay, so that's will we need to continue with those students who don't study. Means I'm not going to teach you physics here because Hamid sir is absent and you are going to have physics class. So we'll shifting your class today for that time. You're just having your chemistry class. Okay, got it?
Okay, sir.
So let's have the we are discussing carbon and its compound chapter. Yes, carbon and its compound. Okay, carbon and its compound. So I think we